This is problem number 4 from section 4.2. It says complete parts a through e below for the function x cubed minus 9x squared plus 15x. It wants you to identify the graph of f of x, identify the turning points, estimate the x-intercepts, estimate any local extrema, and estimate any absolute extrema. So we're going to go ahead and graph this on our TI-84. So I'm at the y equals button. I just typed it in a second ago, so I'm going to leave that in there as so. Then I'm going to go to the window. Now, it took me a second to find the right window. I started out with negative 10, 10, 1, and I ended up, for the y's, using negative 40, 40, and 2. It just took a little bit of playing, and I'll talk to you about how I figured that out. So let's go ahead and hit the graph button. You can see the function's graphed there. The way I figured out that my graph wasn't complete when I was using the window button is I knew that because we have a degree 3, the most number of turning points we could have was 2. Because obviously a polynomial of degree 3 can have at most 3 minus 1 turning points, which is 2. So when I was looking at the graph with the window, when it was negative 10 to 10, it wasn't showing this turning point. And so because it wasn't showing that, I just started to make the y values larger slowly and got to the right window. So make sure that you can use your TI-84 to do that and know how to use that window button really well. All right, now that we've talked about the turning points, we know that there's 2. We might as well just answer part B. And I'm going to kind of set this whole thing up. Part B, part C, D is going to have a min or a max maybe, because that's local min or local max. And part E, we're also going to have an absolute min or an absolute max possibly. Okay, because we're going to answer these kind of all at the same time. So let's get the turning points first. We're going to use this calc button, and we're going to find the minimum first, which the minimum is down here. So it says left bound. We're going to bound it. Right bound. Guess, please. It gives you 5, negative 25. So negative for the turning point, we're going to have one of them being 5 comma negative 25. Now notice I just kind of cut off the extra decimals there. Again, it's guessing for that turning point, so I don't know if that's exact. I'm assuming it's probably 5 is exact. But that's a minimum and it's local, so negative 25 is the local min, and that's not an absolute min. And in fact, there are no absolute mins because this jets off to negative infinity. So this is going to be none for absolute mins. Okay, let's go ahead and use the calc button again. Go to max. We're going to jet over to the left side because this is left bound. Let's left bound. Now right bound. Guess it, please. And it gives really close to 1 for an x value and 7. So this is probably 1, 7 for our turning point. The max then is 7, and there is no absolute max because this jets off to positive infinity here. Last part is estimate the x-intercepts. So we'll go in here, and we're going to click on, remember, we know the x-intercepts are zeros of the functions. We're going to click on 0, and then we can start to estimate those zeros. So I think there's one right in between these two lines. Guess it. Tells me that that is 0. So 0 is one of my x-intercepts, so that's x equals 0. Written terribly, I'm going to write that again, x equals 0. I've got another one, let's go second, calc. I've got another one that is about right here. Let's guess it. It's x equal 2.2. And then finally, the last one It's all the way over here. Left bound, right bound, guess that one. That's at 6.8. And now I have all the zeros of the function. I've looked at the turning points and found the extrema.